All right, so good morning, Year 7. So in today's lesson, I'm going to start with this. The topic that we're going to be covering allows you to do experiments, all right? And a lot of these experiments you can do at home. You can Google and find out. So the protocols for these experiments, okay? If you are going to do this, safety first, always. I don't care how simple it looks, all right? Now, I have a rule in my science lab. You do not remove your goggles. If anybody removes their safety goggles or glasses, they're out of my room for the entire experiment. I don't care if they're year 7 and I don't care if they're year 13. I have never, so yeah, I want you to imagine, I spent decades in a science lab with students, never had a single injury, not even as much as a cut. All right. So, first thing I want to say is safety first. All right. This is key in this. All right. And in every single possible experiment you can do, always make sure your parents are with you. Even if some of these experiments don't look very dangerous, they look quite innocuous, but you always make sure your parents are with you and you make sure they supervise you. All right. Now, if you have any questions about what to do, your parents can go find out. All right. And you're going to be really careful. I let my children do experiments of certain ones. No, Mercy, we can't do it. We're online, Princess. I can show you different ways, and we're going to look at different ways of doing things, but we can't do them, which is an absolute shame. And I'm not a great one for oh, well, you can get these experiments you can do, and they're like apps and simulations, and unless it's electronics, I don't really like them. I think they're meaningless. The thing is, you can do these at home. You don't need much equipment. You can do it with the things you've got in your kitchen. Things like separation techniques. The thing I'm saying, even if it seems really simple, nothing you do without your parents knowing and supervising you. All right. And if they don't know what to do, say, do you know what? I don't know how to do this experiment. You don't do it. And I always start with this. And actually, I have because with me, if this wasn't a virtual lesson, if it wasn't online, you'd actually be sat with me in my science lab. So I'd go through the different equipment, I'd go through different symbols. I have acids and alkalis everywhere in bottles, and you've got to know which ones you can touch. And the answer to that question is none, right? Unless I specifically tell you what you can touch. And that's different. Right, being in a science lab is very different from being in a kitchen. To be honest, you're more likely to get hurt in a kitchen. All right, so I want to make that clear, okay? And I really don't mind. I really don't mind that you go on YouTube, you ask your parents. I've seen some really funny ones, where you can make this foam that goes everywhere. It's really interesting how to do that. Off the top of my head, I think it's sodium carbonate, a bit of fairy liquid and stuff and things like that. I've seen some things. And as I'm saying, always with your parents' consent, and always make sure that you have your eyes protected. Okay, so going back to what we're doing today, what is a mixture? We looked at this. It's where you got two or more substances mixed together that are not, and I'm going to really underline this, that are not chemically combined. All right, they're not chemically combined. Now, you can have elements and you can have compounds that are mixtures. If you look at the atmosphere, all right, it's mostly nitrogen, which is an element. There's some oxygen, which is an element. There's argon, which is an element. However, you can also have a mixture of elements and compounds. Again, looking at the atmosphere, it contains carbon dioxide, CO2. This is a compound. And there's lots of water that we generally call, oh my God, it's raining. And we have lots of water vapor. And these two are compounds because the carbon and the oxygen are chemically combined. Now, if you look at the seawater, I love that as an example. You have water H2O that makes up predominantly most of the sea, but then you have sodium chloride. This is salt. This is a chemical name for salt, and this is a compound. All right. Okay, mixtures versus compounds. Mixtures are not chemically combined. They can be easily separated. We looked at that last week. And they keep their original properties, meaning water is a liquid, and if you separate it from salt, you have water, a liquid, and it behaves like water. Compounds are chemically joined. They are very hard to separate. Right? It is really difficult to break water into hydrogen and oxygen. It's doable, and in year 9 or year 10, I will show you how you split hydrogen and oxygen. It's you again, but very careful. A mixture of hydrogen and oxygen is very explosive. All right. Okay. Now, separation techniques. A really common one is filtration, and it's really easy to do. All right. And I'm going to show you now what filtration can look like in a lab. And in a lab, you'll see complicated equipment. I think this is a buckneful. I'm just pressed the. Okay, let's go for that. Okay, so you can get some interesting looking equipment. Let's get this one up here. You can get some very, so you know, as I said, complex equipment that will look like this. This is filtration setup. But you don't need to. You really don't. And I think there's a big, it's nice, it's cool when you're in a science lab and you've got all the cool equipment. And even at my age now, I still love that kind of thing. I love being in a science lab. But the other thing is science is science. And you can make some really interesting filtration. And I think I do a lot of things with plastic bottles. And, it's, let's just get rid of that. Let's put it here. So, and here's a filtration system, and it can be made of anything. We're actually making one for a pond where we've got things like gravel, sand, and charcoal. And it's huge. It's made from a giant bucket. It's for it's our pond, and that's a filtration system. Okay. So that's filtration. You have evaporation. So that's the only way to separate salt from water. I love chromatography. Chromatography we did. All you need is tissue for it. And I remember doing it at home with my children. And you can do it, and it's really cool. So let me just get this. Copy image. Let's see who's just joined. So filtration you can do at home, and it looks like this. This is filtration. I'll just make a really small version of this image. So filtration, this is chromatography. Let's just move it over there. So this is chromatography. And all you do is draw a line with a pencil. You put some daubs of ink on. You wrap the tissue around. And you can try this, right? As long as your parents are all right with it. Even if you're doing a simple experiment like this, right? You always make sure your parents know. Right? I'm a big one for that. I know it sounds like overkill, but I have never, ever, ever had an accident. All right? So, and that's chromatography. You can see that. I've got an image of it there. Now, distillation is really tough. It is really hard to do distillation, and you use distillation for separating. Now, this is really cool, right? So, the kind of equipment that I would use is something you can get some really interesting equipment like this. It's almost you have to make things, and it is easy to make the things and get on with it. But this is the kind of equipment that we use in a lab for distillation. And it's for separating. So I'm going to have a talk about this one here. This is distillation. And I'm going to put a word here. It is separating. This I don't really like. It's the real time we use it in science is for miscible liquids. Right? is to separate miscible. I missed a C out there. Miscible liquids. Oh, come on, spell it right. There we go. Miscible liquids, such as, e.g., as an example, alcohol and water. Specifically, I don't like using the term alcohol. I want to be precise. I want to talk about ethanol. There are hundreds of types of alcohols, and the one we generally work with is ethanol. And distillation is used for miscible liquids. All right, so keywords you need to know. Solute. Right, and I'm going to show this in terms of mixing salt and water. When you dissolve, mixing salt and water, when you dissolve salt and water to make a salt solution, and we make a salt solution, right? I like to write solution like that to keep it short. Salt is the solute, the thing that dissolves. The solvent, and let me just change colour, is water. This is the solvent, the liquid that does the dissolving. The solution is the mixture. Let's change colour there again. Let's make sure we are colour coded. The solution is the mixture of solute and solvent. Right. When you filter something, the filtrate is the liquid that goes through the filter. So when we had this homemade one, the filtrate is going through, and what is left there is called the residue. This is the residue. Okay. Like all things, this is language. So I've gone through that. I've given you some images, and hopefully that makes sense. You have 10 recall questions. So medium questions, and this really helps. And then you've got reasoning, thinking about, right? And you've got to give examples. And these are really important to me because it allows you to do these experiments at home. Oh my God, I've been talking for 12 minutes.